Hey everyone, Mr. Hauk here. In today's video, we're going to be solving for double angles, sums of angles, and differences of angles given trig values and domain restrictions. Let's go ahead and get started. So previously, we've been proving and practicing with the sum formulas, the difference formulas, and we recently proved the double angle formulas for trig. In this lesson, we're going to be finding exact values, giving trig values, and a domain restriction. So for all the examples in the notes today, we're going to be using this information. We're going to assume that sine of alpha is 4/5, and the alpha is between pi over 2 and pi, which basically means that alpha is in quadrant 2. Because if you think about it, pi over 2, that's 90 degrees. Pi, that's 180 degrees. That's pi over 2. This is pi. So if you're in between, you're in quadrant 2. And we're also given that sine of beta equals negative 2 root 5 over 5, where beta is between pi and 3 pi over 2. This means that beta is in quadrant 3, because again, pi, 180, 3 pi over 2, 270. If you're in the middle of those, you're in quadrant 3, okay? So what we actually want to do before we actually start calculating anything is we want to set up triangles in these quadrants. So I'm going to start with this information here. The sine of alpha is 4/5, and the alpha is in quadrant 2. So set up a triangle in quadrant 2, as you can see right here. Notice that when you set up a triangle in quadrant 2, alpha is coming from the origin right here. And we have, since it's sine, we know sine is opposite over hypotenuse. So opposite of alpha is 4. The hypotenuse is 5 because the hypotenuse is across from 90-degree angle. But we need to figure out what this leg of the triangle is. So we'll use Pythagorean's theorem. I'm going to say a squared, so I'm going to call this side the leg a. A squared equals 4 squared, or a squared plus 4 squared equals 5 squared. 4 squared is 16, 5 squared is 25. Subtract the 16, we get a squared equals 9, and that's going to tell us that a equals 3. But we want to make it a negative 3, since this leg of the triangle is on the negative side of the x-axis. Okay, so that negative 3 is going to go right there. Now let's do the same thing for this bit of information here. Let's construct a triangle in quadrant 3 and make the sine of beta negative 2 root 5 over 5. So here we go. Here's our right triangle in quadrant 3. Notice again the angle is coming from the origin. And we're saying that the sine of beta is negative 2 root 5 over 5. So sine, again, opposite over hypotenuse. Opposite of beta is the negative 2 root 5. Hypotenuse is 5. Notice that the 2 root 5 has to be negative because it's on the negative side of the y-axis. So we need to find the x value, or this side, the adjacent side really. So I'm going to call that a. So using Pythagorean's theorem, a squared plus negative 2 root 5 squared equals 5 squared. Well, negative 2 root 5 squared is 20. And if you have a hard time seeing that, negative 2 root 5 times negative 2 root 5. Well, the negative 2 is on the outside. Negative 2 times negative 2, that gives you 4. And then square root 5 times square root 5 gives you 5. And the 4 times 5 is where the 20 is coming from. So this is equal to 20. And 5 squared is equal to 25, of course. Now we subtract 20 from both sides. We're going to get a squared equals 5. And then we take the square root of both sides. We get a equals the square root of 5. Now again, we want to make this negative because we're on the negative side of the x-axis. Okay, so there's our two triangles in the two different quadrants. And using this information, we want to calculate the cosine of alpha, the cosine of beta, the tangent of alpha, and the tangent of beta. So starting with the cosine of alpha. Well, we know cosine is adjacent divided by hypotenuse. And since we're looking at alpha, we're looking at this triangle here, because that's where angle alpha is. So adjacent over hypotenuse, adjacent to alpha, is negative 3. Hypotenuse is 5. So the cosine of alpha is negative 3/5. Next, we're going to do the cosine of beta. Cosine of beta, well, it's still cosine, so it's still adjacent over hypotenuse. And we're looking at angle beta now. Well, adjacent to angle beta is negative root 5. And the hypotenuse is 5. So the cosine of angle beta is negative root 5 over 5. Next, let's find the tangent of alpha. Well, we know that tangent is opposite over adjacent. We're looking at this triangle since we're dealing with alpha. So opposite of alpha is 4, adjacent is -3, so it's -4/3. And then finally, we'll find the tangent of beta. Here's angle beta, so we're using this triangle. Again, we know tangent is opposite over adjacent, so opposite of angle beta is -2√5, adjacent is -√5, so we have -2√5 over -√5. Notice the negatives will cancel, and the √5s will cancel. All we'll have left is 2. Okay? So now, for both of these triangles, we have the sines, cosines, and tangents. All right? So all that information collected is right here. And I put it at the top of this page because we're going to have to reference this information constantly. Okay? So here's the sine, cosine, and tangent of alpha. Here's the sine, cosine, and tangent of beta. All that information taken from the first page. And what we want to do is we want to do a few calculations. Some of them are going to be sum formulas, like right here, cosine of alpha plus beta, sine of alpha plus beta. We have a difference formula, tangent alpha minus beta. And then we're also going to get some practice with double angle formulas. All right, let's start with this first one right here. We want to find the cosine of alpha plus beta. Well, cosine of alpha plus beta, we have a formula for that, of course. We've been working with it the last few lessons. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Well, we know that cosine alpha is -3/5. We know that cosine beta is -√5/5. We know sine alpha is 4/5, and sine beta is -2√5/5. So we plug in all those values. Next, we're going to go ahead and multiply. -3√5, or -3/5 times -√5/5. That's going to be 3√5/25 right here. And then 4/5 times -2√5/5, that's going to be 8√5/25. Now, adding these together, they have a common denominator, so we can add the numerators. And in the numerator, 3√5 plus 8√5, since they both have the same square root, we add the coefficients on the outside, so 8 plus 3 will give us 11√5/25. Okay, so not too bad. Next, let's go ahead and calculate sine of alpha plus beta. Well, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, so that's just the addition formula for sine. And let's go ahead and plug in all these pieces. Let's plug in the fact that sine of alpha is 4/5, cosine of beta is -√5/5, cosine of alpha is -3/5, and sine of beta is -2√5/5. Again, multiplying and simplifying, 4/5 times -√5/5, that's going to be -4√5/25. And -3/5 times -2√5/5, that's going to be 6√5/25. Once more, common denominator of 25. That means we can add the numerators together. -4√5 plus 6√5 will give us 2√5/25. Okay. Next, let's do a difference formula calculation. We want to find tangent of alpha minus beta. Well, following the formula for tangent subtraction, that's going to be tangent alpha minus tangent beta divided by 1 plus tangent alpha times tangent beta. Well, again, following the pieces that we found on the front page, we know tangent alpha is -4/3, and we know tangent beta is 2. So let's plug in those values here. So -4/3 for tangent alpha, minus 2, which is tangent beta, divided by 1 plus -4/3 times 2. And now we're going to start to simplify. So I went ahead and, let's go back down there. Went ahead and took the -4/3 times 2, multiplied that together. That's going to give us -8/3. So we have -4/3 minus 2 divided by 1 minus 8/3. Next, I'm going to go ahead and get some common denominators. So I'm changing the -2 into -6/3 so that we have a common denominator of 3. I'm also changing the 1 into 3/3, to get a common denominator of 3. Continuing my work up here, We'll notice that negative 4 over 3 minus 6 over 3, so negative 4 minus 6, that's negative 10 over 3, over 3 minus 8 gives us the negative 5 over 3. Now when going to simplify, we have a fraction inside of a fraction. Denominators are the same, so they'll cancel out. That's going to leave us with negative 10 over negative 5, which is just 2. So the tangent of alpha minus beta is equal to 2. All right. So those are some examples of our addition and subtraction formulas. Now let's look at examples for the double angle formulas. The first one here, we're going to calculate the tangent of 2 beta. Well, in the previous lesson, we found, or we proved, the double angle formulas. So we know that the tangent of 2 beta is going to be 2 tangent beta divided by 1 minus tangent squared of beta. That's the formula that we proved. And we know that tangent of beta is 2, something we showed on the first page. So we're going to plug in 2 for these tangent of betas. That's going to give us 2 times 2 in the numerator and 1 minus 2 squared in the denominator. Remember that tangent squared beta really just means tangent of beta squared. Okay, so tangent squared beta, that's 2 squared. Well, 2 times 2 on top is 4. 1 minus 4 on the bottom, that's going to give us a negative 3. So we get negative 4/3 when it's simplified. All right, next, let's try to find the sine of 2 alpha. Well, sine of 2 alpha, we proved in the previous lesson, again, we proved the double angle formula for sine. Sine of 2 alpha is going to be 2 sine alpha cosine alpha. And let's look at sine alpha and cosine alpha. Sine alpha is 4/5. Cosine alpha is negative 3/5. So let's do some substitution. That's going to be 2 times 4/5 times negative 3/5. Multiplying across the top, think of this 2 as a 2 over 1. So 2 times 4 times 3, that's going to be 24, really negative 24 because of the negative here. And then across the denominator, 5 times 5 is just 25, so we get negative 24/25. All right, and our last problem in the notes, let's try to calculate the cosine of 2 beta. So 2 beta, we know is equal to cosine squared beta minus sine squared beta. Again, that's a result that we proved in the previous lesson. And let's go and look at cosine beta and sine beta. So cosine beta is negative square root of 5 over 5, and sine beta is negative 2 square root of 5 over 5. So we're going to get some square roots practice here. All right, so we're going to do cosine squared minus sine squared. Well, here's our cosine, and then we're going to square it. Also, here's our sine, then we're going to square it. So let's think about this for a moment. Negative root 5 over 5 squared. So negative root 5 over 5 times itself. Well, the negatives are, of course, going to cancel, so we're going to get a positive. Square root of 5 times square root of 5 is just 5, and then 5 times 5 is going to be 25. So we're going to be getting 5 over 25. Same deal here. Negative 2 root 5 over 5 times itself. Well, negative 2 times negative 2 is going to give us 4. Square root of 5 times square root of 5 is going to give us 5. 4 times 5 will give us 20. That's the top. And then the 5 times 5 gives us 25, the denominator. So that's where the 20 over 25 is coming from. Well, it's a common denominator of 25. So 5 minus 20 gives us negative 15 over 25. And when you reduce that, you get negative 3/5, which is our answer. Okay, so this is how we would handle problems like these, especially when, again, you're given a trig value in a domain like this. See how we're given sine of alpha, sine of beta. We're given domain restrictions, told which quadrants that they're lying in. You end up making triangles, finding the 6 trig functions, the sine, cosine, and tangent for each of the triangles, and then using those to calculate your sum, difference, and double angle formulas.